Section 2, solving equations by using addition and subtraction. Hopefully this is a review, and let's go. So first thing we're going to talk about is addition property of equality. So if an equation is true and the same number is added to each side, the resulting equation is true. So in symbols, that would be A equals B, then A plus C equals B plus C. So we can add that third letter or number to that. What that looks like in an example, if I take 7 on both sides, so 7 equals 7. If I add 3 to both sides, the result is going to be equal. Same thing as if I added a negative number, so still adding, even though technically you're taking away. Adding a negative number to both sides will take it down, and they will still end up equal. But the point is, if you do the same thing to both sides, they end up being equal. Same goes for the subtraction property of equality. So if an equation is true, then the same number added or subtracted from each side will result in a true equation again. So A minus C equals B minus C. So 17 equals 17. If I take 9 away from both sides, it'll turn into 8 equals 8. If I subtract 8 from both sides, it can turn into a negative number. That's okay. So equivalent equations are two equations with the same solution. So if I ended up with two different numbers, two completely different equations, but they have the same solution, that's an equivalent equation. Solve an equation to find all the values of the variable and to make the question a true statement. All right, so let's see what this all looks like here. So solve this by adding. Okay, so solve this. So first thing we're going to take is the original equation. I very much recommend writing this so you can do it vertically. It makes life a lot easier. Then you're going to add 12 to both sides. So we added 12. So your answer ends up being H equals, man, they did not do that nicely. All right, so let's do this my way. I would add 12 vertically like this. Add 12, and then I do this nice little cross thing here. So this will end up being negative 15. These cancel because it goes to 0, and then H comes down. H equals negative 15. So that's how I would come up with that answer, which is what they wrote here, but I don't know what they were doing up there. I just think that would make more sense. So check. In order to check this, you'd actually put it back in. So we would see, we put 15 back into the original equation. So that would be negative 15 minus 12 equals negative 27. We add those together, it goes negative 27 equals negative 27. So you can do that on the test to make sure if you check your answer. All right, solve this by checking your solution. So they're going to write the equation first. I'm going to do it my way and make sure it's a little easier. So I subtract. Oh, that's what they want us to do. They want me to add a negative 63 to both sides. So add a negative 63 to both sides. I think that comes out to 29. Yeah. So when we add those together, cross that one out, K equals 29. And that would be my answer. Here's how the book does it. Yeah, so your answer comes out down here. And the reason this works is because 63 plus a negative comes to 0. That's what the cancel out here was. And 92 plus a negative 63 comes out to 29, which is what we did on this side. Pause this and try. Go. All right, so we write it out. And we're going to add 24 to both sides. And those will cancel. A equals, we add these together. You could do it on here, which would be 10, carry the 1, 3, and 4. Or you could do it in your calculator, doesn't matter. And so it's going to come out to A. All right, try this one. All right, so T plus 22 equals negative 39. See, they still want me to add a negative 22. Why they don't just let me subtract, I don't know. 22, those will cancel. Add these together, which is actually yeah, you're actually adding a negative number to a negative number, so technically I completely add them. So that comes to 1, that will come to 6, and keep the negative. Negative 61. All right, solve this by subtracting. So we rewrite the original equation, and then we're gonna subtract 102 from both sides. Say they do it sideways, I prefer vertical, that's okay. Keeping going, subtract that from both sides, these will cancel. And this will come out to 66. C equals 66. And those are y. You could put that back in, and let's give that a shot. All right, so it's a pretty big number here, so that's okay. That's what calculators are for. So 129 plus k equals negative 42. Wait, there's nothing in front of here. What do I do? Oh, it's positive if there's nothing there. So I can subtract 129, subtract 129 from both sides, which technically means adding because they're both negative. So 42 plus 129, 171, negative 171. All right, so now they give me two options. Solve it by adding or subtracting. So we're going to do that add a negative number thing that we did a little bit ago. So method 1, use the subtraction property of equality. So I take my original equation. I'm going to subtract 3/5 from both sides, which doesn't come out easy. So technically, I would need to find the least common denominator. So I would multiply both 3/2 and 4/5 over here. These just cancel out nicely. These I'm going to have to adjust. So they multiplied one of them by 3, or say one of them by 5. So this one's like times 5. That's how we got the 10. This one's times 5 over 5 over 5. So that's where the 15 comes from. 15 and 12. So now, and don't forget the negative sign. 10 minus 12, that's how we get negative 2/5. All right, the other way to do it would be to use the addition property of equality. So we're going to add a negative number to both sides. Again, we're going to have to adjust these for the least common denominator. So again, they don't really show it here, but I would have written this out with a 2/3 and then times 5 over 5, and this one times 3 over 3, and 10 times 3 is 12, is 10, so that's how we get that. Pause this, give it a shot. All right, so it's another one of those, don't freak out, it's fractions. Woo, it's not that bad. 2/3 plus y equals 5 over 6. So I'm going to subtract 2/3. Those cancel out nicely. Over here, I need to subtract 2/3. That doesn't quite work, so I'm going to multiply this one. Actually, that I can leave. I'm going to multiply this by 2 over 2 so that the denominators go to 6 each. So it's going to be subtract 4/6, so 5/6. So 5 minus 4 will come out to 1/6. And so then y equals, I just brought the y down, y equals 1/6. Write an equation for the problem, then solve the equation. 14 more than a number is, 14 more than a number is equal to 27. Find this number. All right, so we write it all out here. 14 more than a number is equal to 27. 14 is a number. 14 plus, I don't know what number, n equals 27. Now we got to solve it. So we'll subtract 14 from both sides. And then that answer comes 27 minus 14 is 13. So 14 and 14, these would cancel. That cancels, that cancels. That's what happened here. 27 minus 14 comes out to 13. All right, try this one. Okay, so 12 less than a number. 12 less than a number is equal to negative 25. So 12 less than a number. Oh, those will be flipped. A number minus 12 is equal to negative 25 plus 12 plus, wow, that's a horrible 2, plus 12. That would be a negative 13. And those cancel, bring down my n, negative 13. All right, Washington Monument in Washington, D.C. was built in 2 phases. During the first phase, it was 152 feet. During the second phase, additional construction resulted in the final height being 555. How much of the monument was added during the second phase of the construction? Write an equation to solve this problem. So I would look at the height, a height of 52 feet. Monument's final height was 155. How much of the monument was added during the final construction phase? So write an equation to solve this problem. So in words, the first height plus the additional height equals 150 or equals 55. So we're going to need a variable for this. So they're going to use A, which is fine for additional height. I might have used H for height, doesn't matter. So the first height plus the additional height equals 55. Let's actually look at these over here. So I have height of 152. So 152 plus an additional height, so they used A, equals 555. That's what I would have done, so I would have taken the numbers that I underlined. So how much was added? A number. They rewrote it out, which is fine too. So 152 plus additional height A equals 555, same thing. So now we solve it. We're going to subtract 152 from both sides because that is the inverse, the additive inverse of 152 would be negative 152. So that's why we're going to do that to both sides. And we punch that into our calculator, gets out to 403. Not done yet. What was actually done there? The original question was, how much of the monument was added during the construction phase? So the answer, I have to answer that, would be 403 feet were added during the second construction phase. All right, last shot, go. All right, the Sears Tower. I was just around that area in Chicago right before school started this year. Hopefully you don't see this in multiple years after this. Anyways, moving on. So the original height, or the height to the sky deck is 1,353 feet. The actual recorded height is 450 feet. In 1982, they added twin antenna towers, which did not count for the record, for a total height of 1,770 feet. How tall are the twin antenna towers? So we take the recorded height. They may have given us too much information here because I only need 2 things. So how tall are the antenna? So I'm going to use A for antenna. The total height is 1,707. And I need to, which one of these numbers? The height of the sky deck or the actual recorded height? I think we're going to go with the recorded height because that's the top of the building. The sky deck, if you've been there, is not quite at the top of the building. So the height that we're trying to figure out is from the top of the antennas to the bottom of the antennas. The bottom of the antenna is going to be there. 1,450. Subtract that from both sides, the additive inverse. Punch that into my calculator. 257 is what I get. And see you in class.